And finally, we need to find the fourth order Taylor polynomial for cosine of 2x. So let's do this. So f of x is cosine of 2x. The first derivative is going to be negative 2 sine 2x. I'm just using a little chain rule there. The second derivative, the derivative of sine, is cosine, but we're going to have negative 4 cosine 2x again because I'm using the chain rule. The third derivative, the derivative of cosine, is negative sine, so I'm going to have a positive 8 sine 2x. And the fourth derivative of sine is cosine, but we have to use chain rule, so I'm going to have 16 cosine 2x. So when I plug in a 0, I get a 1, I get a 0, I get a negative 4, I get a 0, and I'm going to get a 16. So when I set this up, I'm going to have, so I'm going to say cosine of 2x is going to be equal to 1, 0, and then I'm going to have minus 4 over 2 factorial x squared, and then I'm going to have a 0, and then I'm going to have plus 16 over 4 factorial x to the fourth, which, let's see, simplifies. I could simplify this if I wanted. I'm just going to compare that to what I know we had about cosine, right? Regular cosine x was 1 minus, let's just check this, 1 over 2 factorial x squared plus 1 over 4 factorial x to the fourth. I'm going to write this as 1 minus, I'm going to leave this as 2x squared over 2 factorial plus, and I'm going to look at this 16x to the fourth, and I'm going to think of it as 2x to the fourth over 4 factorial, just to kind of see what's going on here. So it looks as though if this is my expansion for cosine x, then anytime I have some sort of a composite function, whatever I'm plugging in here, I can just plug in for x. Interesting.